Here we are, we're on C14 now. So notice, week 2, Monday. I haven't graded anything you've turned in yet, okay? Here, let me pause this here. So this week by Friday, on your Student Connect, you're gonna see C11, C12s, and you're gonna see your grades for everything by Friday. I haven't graded anything you've turned in yet, so don't stress out if you don't see your grade yet. By Friday, you'll see your current grade. A lot of this orientation stuff, the first few assignments are easy to grade, so it's not a big deal. But notice, this is gonna be the 4th day now. You should be receiving your 8th stamp, which is really a half a credit now. We're at the halfway credit mark by the end of today. We've done C11, C12, C13, now we're on C14. And let me show you the game plan. From now on, you'll see a PowerPoint. For every assignment, you're gonna see a PowerPoint that says Math 3A, C14. And this kind of gives you the lowdown for the whole day if you're absent. Exponents intro, we're gonna get into exponents today. Here's the agenda. Warm up, we already did the multiplication tables. That's your R stamp. Notes, we're about to take notes. That's gonna be part of your R stamp. And then you're gonna do a flip grid, which is your DMT, what I'm gonna grade today. What's the learning objective? How do I simplify expressions with exponents? The bell work you already did, okay? So today the bell work and the warm up are kind of the same. Sometimes they'll be different. Sometimes they'll give you a warm up after the bell work, but today's warm up is just the bell work. This is for second period, so ignore that. So we're gonna get into notes right now. And the academic expectations, take complete notes, ask or answer questions when not directly prompted, participate. Be respectful, be safe, be productive, right? To get that R stamp. So, coming back over here, the note guide, you can open this note guide up with Cami and take notes with Cami if you want to go electronic. Or you can take notes on hard copy. Okay, so we're going to take notes first. Let me go back to this. So we'll take notes, and then, get that for me? For the DMT, you're going to do a flip grid. Flip grid's like a online Instagram, Snapchat kind of thing.
No, it's not.
Well, whatever it is. It's like social media. Good morning, Miss Dominguez. How would you describe it?
As a Google slide.
Have you done a flip grid before?
I've used it before.
So you're gonna click there, and then go to my flip grid after the notes. So what you'll post is what I'm gonna grade, and then you're done for the day. If you're done early, you can work on anything you owe me from the past, or you can work on some extra credit. I have some extra credit you can work on. That's basically it. We're gonna take notes. And then you'll do a flip grid. That's the game plan for today. Again, I haven't graded anything you've turned in. You'll have your current grades by Friday. But for now, who would like to take hard copy notes? Raise your hand, because I got copies of the notes. Okay, so you'll see this on top, this on page 1 of your notes. So let's go ahead and dive in here. Get my pen ready here. Let's go Dodger Blue, since it'll be a Dodger Stadium today. I'll go Dodger Blue. So, power, exponent, base, some basic vocab. It says put it in your own words. So you're just going to follow my example. You're going to write down what I write down for these notes. Now, when it says put in your own words, let's put it in. I'm going to create my own words so we can get to the heart of what these words mean. So what I want you to do is go and write 8 to the 4th power. 8 to the 4th power.
What are you writing?
Just anywhere, yeah, anywhere in the notes. So you got the space. You got all that space there? Yeah. Just take up all that space there. So on Cami, you can write, there's markers there, pens, I think, options. 8 to the 4th power. Now, the exponent, watch this now. The exponent is, put an arrow from the word exponent to that little number on the upper right. That's the exponent. The base, go ahead and draw an arrow from the word base to the 8. Pretty simple so far, our notes. What do you think the power is? Any guesses? So the base is 8, the exponent is 4, which is, some of you have probably already seen this in some past math class or something. What would the power be though? So that's the exponent. Any guesses? For a Monday morning. Any Monday morning guesses?
No.
Don't worry, it's alright if you get it wrong.
I'm not gonna get
I'm not gonna make fun of anybody. Just when you leave, I'll talk smack about you. Just kidding.
that's what my ear would be.
Was it the left side or the right side if someone's talking smack? It's the left one, huh?
Yeah.
Any guesses? Dominguez, Catarino, De La Rocha, any guesses?
4.
4 is the exponent.
Is the power like what that makes? Cause don't you have to
Ooh,
like multiply 8 4 times?
right, it's 8 times 8 times 8 times 8, right? In other words, this means, thank you, Miss Diaz. So the power is really, the power is the whole thing. It's the base with the exponent. So we're gonna put power, the whole thing. So any base raised to an exponent we call a power. You see? Anything raised to an exponent, the whole thing, the base with the exponent is called a power. There's some basic vocab out of the way. We need to get our terms straight before we start talking mathematics, or we're going to be talking past each other, and it's going to be chaos. It's not going to be rational thought. I mean, I don't even know what you guys understood what I just said, but all right.
You're funny.
Oh, we're gonna have lots of fun Diaz this quarter. Trust me. Yeah. Scientific notation we're not gonna cover right now. Don't cross it out. We might cover it later if I have time. Let's get to page, actually that first, where it says core concepts at the bottom. Here we go. Here we go. Let me paste this puppy. All right. Put that down here. Nice. And let me go down a little bit more. Do a few more here. Nice. Rocking and rolling here. Gotta get used to this board. Because during COVID, the whole year of COVID, I kind of forgot all my skills a little bit. Because I was working from home and I don't have my ViewSonic board at home. So I'm a little rusty. So I plead for your patience. Last but not least, there we are. The last two. Okay, beautiful. Beautiful, beautiful. So on your notes, what I'm gonna throw at you today is 7 rules of exponents. In other words, how do you deal with expressions? How do you deal with mathematical statements that have exponents? That have these? What are the rules to interact with statements in math that have that? That's what we're going over today. That's the big picture. And there's 7 rules, and I want you on your own notes, just go to number them with me. I like the paintbrush better. Dodger blue, I'm going to the Dodger game. Did I mention I'm going to the Dodger game? Never mind. 2, So the first one is 0 exponent. 2 is negative exponents. The third rule is the product of powers property. So these are just rules. Okay? Rules of exponents. The fourth is quotient of powers. The fifth, so number them with me, is the power of a power property. The sixth and the seventh, power of a product property. And finally, last but not least, is the seventh is power of a quotient property. So number those puppies with me. So all Mr. Mungia is going to do is I'm going to go through each of the 7 and give you just a few examples of each one, how it's used. And then you're going to go to your flip grid and you're done for the day. Easy Monday. I don't know what to do. This is very easy, straightforward Monday. We'll take notes. When you press play on my flip grid, my video, I tell you what to do in your little video. And by the way, your videos are not accessible to anybody but me, so you don't have to stress out about people watching you. This is me. So let's talk about each one. So the first one's a 0 exponent rule. Every rule gives you an example with numbers and an example with algebra. When they put the algebra example, it's always with a variable, if you notice. Every little algebra example is with a variable. So look at here's in words. It's describing what the rule says in words right there. For any non-zero number a can mean any number. For any non-zero number a to the 0 power is 1. Okay? So non-zero numbers are just numbers that are not 0. And if it's raised to the 0 power, it's going to be 1, except 0. So how many numbers in the universe are not 0? How many numbers are there that are not 0? Go positive direction on the number line, go negative direction. How many are there that are not 0? How many numbers are there that are not 0? Let's see, think. Drink some coffee. Let me ponder that. Anybody?
Isn't it like infinite numbers?
Right, there's an infinite amount of numbers that are not 0. And this is saying, look, all those infinite numbers that are not 0, if you raise any of them to the 0 power, it's going to be 1. Except the one that's 0. If it's 0 to the 0 power, it's undefined. The number doesn't exist. So there's numbers that don't exist. I'm not sure if you're aware of that. Things that don't exist don't have definitions. And the things that don't have definitions are undefined. They don't have it. So they gave you 2 examples. Let me give you 2 more. Diaz, what's your favorite number?
12.
12 to the 0 power. Let's take Diaz's favorite number to the 0 power. Diaz's favorite number is a non-zero number. It's raised to 0 power. It's 1. I don't know what else to tell you. Let me use a variable now. X to the 0 power is 1. So just fit this somewhere inside your notes, wherever you want. This is your note guide. You're not going to turn this into me. This is for you. So wherever space you see on your note guide, you write where you want. It's your note guide. Let me give you one more example. De La Rocha, give me the first negative number that comes in your mind. Spit it out.
3.
Negative number.
Oh.
It's all right. Let's go negative 3.
4.
Negative 3 to the 0 power. Is negative 3 a non-zero number? Is that a negative 3 a non-zero number?
No.
Is negative 3 not 0?
Why? Because it's a negative?
Right, it's not 0, huh?
No.
So it is a non-zero number. In other words, any number that's not 0 is a non-zero number.
Yeah, right.
So negative 3 is a non-zero number. I'm raising it to the 0 power. It's 1 also. That's all this rule is saying. Any number raised or anything raised to the 0 power is going to be 1 except 0. Rocking and rolling. Let's go on to the second rule. That's all I'm going to be doing. I'm just going to comment on every rule. What if you have a negative exponent? This is funky. Negative exponents. Okay. Here's what happens if you have a negative exponent. You reciprocate the number and the exponent becomes positive. Phone's away right now, Delocha?
What was that?
Phone's away right now?
I don't know.
It's all right. So notice, 4 to the negative 2 power, if you put that over 1 and make it into a fraction, notice reciprocating is that fancy schmancy word from way back in maybe junior high or elementary school. The reciprocal is when you flip the fraction. So all this rule says, hey, look, you have a negative exponent, just flip the fraction and make the exponent positive. That's it. That's it. In other words, let me give you another example. Catalina, what's your favorite number?
6.
What if I took 6 to the negative 3 power?
The reciprocal would be 1 over 6 to the third power.
Thank you. I'll make that into a fraction and then take the reciprocal. It's going to be 1 over 6 to the positive 3. In other words, you make that exponent negative. Let me do it with a variable, just for giggles.
Use an n.
Let's do it. N to the negative 50th power.
Over 1.
Exactly. So just the first thing is just making a fraction. The way to make anything into a fraction is put it over 1, because everything can be over 1. And then flip that puppy. 1 over n to the positive 50th. Come on. No one's crying yet, right? We're good?
Almost.
I have a teddy bear if you need to plug a teddy bear if you start feeling bad. Right there, my Dodger one in the back. My Dodger teddy bear. Let's do this. Okay, so we got 2 under our belt. Let's go 5 more. We'll go a little quicker now. All right. Product of powers property. I'm going to go ahead and I'm not even going to worry about the let A be a real number and M be integers, because that's too fancy schmancy language for us right now. So I'm going to cross that out. Yeah, I'm not going to worry about that right now. I want to get just right to, what does this rule say? To multiply powers with the same base, that's what it says. Add the exponents, that's it. Look at the example they gave you, 4 to the 6th power times 4 to the 3rd power. Look at, they have the same base. Remember we went over what a base is to start? The base is the part of the power that's being raised to the exponent. So this is saying, look, if you're multiplying 2 powers that have the same base, just add the exponents. So 4 to the 6th power on your notes times 4 to the 3rd power is going to be 4 to the 6 plus 3 power. They're adding the exponents. That's it. How about algebra? A to the m times a to the n as in Nancy is going to be a to the m plus n. I'll give you 2 more examples. De La Rocha, what's your favorite number?
23.
Is that Jordan?
Huh?
Michael Jordan?
No, that's my birthday number.
Oh, okay. Because Jordan's my favorite.
Ooh.
So watch this. De La Rocha's number, 23 to the 4th times 23 to the 2nd. Notice, I'm multiplying 2 powers that have the same base. The base of both of these is De La Rocha's favorite number, is 23. So all this says is, look at, add the exponents. Right here. That's what the rule says. Add the exponents. It's going to be 23 to the 6th power. Now we could leave our answer as a power, or we can actually use a calculator and start doing 23 to the 6th power, just as a number. But for now, our purpose is just leave it as a power. 23 to the 6th power, we're done. Let me give you one with the variables. How about q to the 7th times q to the 8th? Again, just find any space in your notes to write these examples down. That's going to be q to the 15th. My coffee has kicked in. Yep. Oh, yeah, the bad numbers. Rocking and rolling. Let's keep going. Question so far? Okay, let's keep going. Here we go. How about quotient? It's the same. Look at number 3 is the same as number 4, except number 4 is just dealing with division instead of multiplication. You have the same base, and you're dividing. You subtract the exponents, people. Dominguez, what's your favorite number? 20 what? 27. Watch this. 27 to the 10th power divided by 27th to the 2nd power, let's just say. Same base, 27, that's Dominguez's favorite number. This rule says, hey, look, I'm gonna the fancy schmancy stuff, I'm gonna go ahead and cross out. Let's just get right to the words and how to describe in words. To divide powers with the same base, subtract the exponents. So 27 to the 8th, huh? Rocking and rolling. 3 more, we're done. You do your flip grid. Don't drink more coffee. Power of power. Think about the title. Power of a power. In other words, you're taking a power and raised to a higher power. An exponent on top of an exponent, in other words, right? That's kind of what's going on here. Check it out. Look at 4 to the 6th, all to the 3rd. You got 4 to the 6th, then you got another exponent outside the power. Well, look at what, again, cross out the fancy schmancy stuff. If you want. If you like the fancy schmancy, leave it. Multiply the exponents, it says. What's your favorite number again?
12.
Watch this. I'm going to take De La Rocha's number again. 12 to the 2nd, and I'm going to raise that puppy to the 7th, let's say. The power is 12 to the second. 12 to the 2nd. That's the power. Now I'm raising it to a higher power, so that's going to be 12 to the 14th. Notice. Cool. Pretty straightforward, I trust. Let's do it with a variable. Let's go t to the 8th raised to the 10th. Power raised to the power. Power of power. Again, just find any space around that rule on the notes to write these down. Someone give it to me. It's going to be t to the what? Anybody?
T to the 18th power.
18th? You're adding the exponent.
No, T to the 80th power.
80th. Gracias. Nice. Look at that. So power of power, just multiply. Last 2 rules. You guys are doing good. And tomorrow we're going to dig into some examples of how to use all of them when we're trying to simplify an algebraic expression. It's going to get crazy tomorrow. Here we go. Power of a product. Now, product is a fancy schmancy word for multiplication. Let's put M-U-L-T, multiplication. Power of multiplication. Look at inside parentheses, they're multiplying the 3 and the 2, and they're taking everything to the 5th power. So the key thing here is they're multiplying. Look at that, dot means multiplication. So you're multiplying items in parentheses and you raise all that items in parentheses to a power, then you can take every item to that power individually. Look at the algebra example they gave. A times B, look at they're multiplying. Well, you could take each factor to the m power. They took the A to the m power and then B to the m power. Give you an example. So how about x, y, z? Got multiplying. Whenever you have variables next to each other, that means multiplication. X times y times z, all to the 8th, let's say.
X to the 8th power times y to the 8th power.
Exactly, very good. It'll be x to the 8th, y to the 8th, z to the 8th. You just take every factor that's being multiplied to that power. So far, so good. There we go. And this is kind of the same thing as number 6, the power of a quotient. Power of a product, that's multiplication. Power of a quotient is when you're dividing, and every item that's being divided is being raised to a power. Then you can take the numerator and denominator to that power. That's it. Look at the 3 as a numerator, and the 2 as a denominator, and they took both the numerator and denominator to the 5th power. Simple. Not a big deal. So, here's another example. How about x divided by y to the 10th power? Hit it.
X to the 10th power over y to the 10th power. Right?
Give it to me one more time. Go.
X to the 10th power over y to the 10th power.
Exactly. No big deal, you guys. We're going to practice more tomorrow using these rules of exponents. You have about a half hour now to do the flip grid. You're going to need to know, all you're going to do is, well, watch my video and I tell you what to do. So go into your flip grid, mark it as done when you're done, and you get your 2 stands for the day.